Hello and welcome to thermodynamics. We're going to talk about heat and thermal energy. Heat is thermal energy that is transferred between objects. Heat, which is measured in Q, is affected by amount, temperature, and type of substance. Thermal equilibrium states that two objects of thermal energy are in equilibrium with each other at the same temperature. Therefore, we have the equation heat equals mass times capacity times change in temperature. In this lab, there's room temperature water that gets heated in a metal cube that is heated inside of that. Then it will be transferred to another cup and the temperature will be taken. Using the equation heat equals mass times capacity times change in temperature, we can use thermal equilibrium to determine the heat capacity of the metal. When plugging in the values, we can find a change in temperature using final minus initial, and the water capacity, which is measured in joules, divided by kilograms. When simplifying, we can use absolute values, and in the end we find heat capacity. Heat can be either negative or positive. Endothermic, or positive, is gaining heat, while temperature is increasing, and exothermic is a loss of heat. This is another example of conservation of the heat of a system plus the heat of the surroundings are equal to zero, which is the net energy. This is conservation of energy, which also can be worded into exothermic and endothermic, because when they're put together, that also equals zero. Energy can be gained or lost. Heat transfer is what causes phase changes of different objects. Changes can go from solid, liquid to gas, or the other way around, depending on whether it is gaining or losing energy. These processes are called freezing, melting, vaporization, sublimation, deposition, and condensation. In this graph, it is measuring the heat added. When the graph is increasing, it is endothermic and it is gaining heat. This part of the graphic can use heat equals mass times capacity times change in temperature. The temperature also increases as well as the kinetic energy. When heat is being added but the temperature is not increasing, this signifies a phase change. It is exothermic and it creates new bonds to alter the substance physically and chemically. The plateau of the graph depicts this change. The change is measured by mass times latent heat. This is when the ice is melting and turns into water. The heat is also referred to as enthalpy. When the temperature increases, so does the kinetic energy. When there's a phase change, then there's also potential energy. Thermal equilibrium and kinetic energy are both examples of conservation of energy. As you remember, kinetic energy plus potential energy equals zero. Enthalpy is a measure of change in heat and a physical or chemical change. It is the heat absorbed or released in order to raise potential energy. You can find enthalpy if you balance an equation and measure its direction of process. The change in enthalpy is equal to the enthalpy of the product minus that of the reactants. With the values of enthalpy in its stable form already given to us, we can calculate whether it is an endothermic or exothermic change in energy. After plugging in the values from the equation, you can see that the reaction is positive and therefore endothermic, or acquired heat. When a reaction is endothermic, it breaks bonds. Energy is released when new bonds are formed. In this reaction, energy was released and new bonds were formed.
Spontaneity is whether or not a reaction will take place. It can be calculated by using Gibbs' free law, which is a change of G equal to the change in H minus the product and temperature of change in S. These together are driving forces, and when they are substituted in the equation, they can find whether or not it's spontaneous. A negative change in G is always spontaneous. Find entropy in two simple ways. First, with the reactions increase or decrease in molecules. An increase in molecules after an experiment is more disorder, and disorder makes the entropy positive. The second way to find whether it is positive or negative is to observe the phase changes. In the change of ice to water, the change is going from solid to liquid. Solid to liquid to gas is an increase in disorder as well, which will also create a positive entropy. After finding the endothermic and or exothermic entropy and enthalpy, you can use this chart to determine whether something is spontaneous. The chart is based off of Gibbs' free law, and sometimes boxes are affected by whether temperature is high or low. The entropy and the enthalpy are driving forces, however, so they are the main energy and power behind the spontaneity.
Created using Powtoon.